Hello everyone, and in this video we're going to be doing start from Pwnable.Tw. So I knew this website existed, but it has harder challenges, so I had kind of avoided trying any of them. And this afternoon I was able to do the first one, so I figured I'd do a video on it. You can't do videos past this baby stack, but I doubt I'll get there anytime soon regardless. Probably only be able to do the first two and then leave it at that, but we'll see. So for start, it says just a start, and then it gives you a host and a port, most likely of a container running the binary, and then also gives you the binary to download, which I've already done. So the first thing to do is to run it and see what it does. So it prints let's start the CTF, and then just closes. So we can try and crash this, give it a large amount of input. Let's just do 300. And we get a segmentation fault, which means we have some kind of buffer overflow. So we use 300 bytes. So what we're gonna do is we're gonna use this online pattern generator again, and we're going to take this unique string, this pattern here, copy this, open the binary with GDB. We're going to run it. It says let's start the CTF, paste in the pattern, and you see we have our seg fault again. And we have this value in the extended instruction pointer, which I already have that in there, sorry. Paste that in there, and we need 20 bytes to reach the return address, and then the next 4 bytes will go inside of the EIP. So that's nice. And now sometimes what you do with these overflows is you put your shellcode inside of the buffer and then you return to that. But in this case 20 bytes is too small for us, so we need a different address on the stack that we can return to and then execute our shellcode from. So to find that, we're gonna need to leak an address somehow, and we're gonna reverse this a little bit with Radare. So just R2 start, and then S main V for visual mode, V again, and we get to see the disassembly. So first thing they do is they save the stack pointer by pushing its value. They clear all the registers. They push these immediate values onto the stack. Then they set up the write syscall, which if you look at the 32-bit syscall table, number 4 is sys_write. So in EAX you put hex 4. In EVX you put the file descriptor. ECX you put a pointer. And then EDX is the size, or the number of bytes. So hex 14 for the size, 1 for standard output, 4 for the syscall number, and this pointer here inside ECX and the pointer that goes inside ECX will actually be the top of the stack, since they're moving the stack pointer's address into ECX. And then they call the system call, and it'll print out presumably let's start the CTF. Then it sets up the read syscall, which will read hex 3C bytes, blah blah blah, and then 3 is this syscall number that goes into EAX or AL here, and then it finishes. So what we can do is we can, in order to leak an address, we can leak the stack pointer, the address of the stack pointer actually, by putting this address into the extended instruction pointer with our initial overflow. So if we return to this again, Then we're gonna move the current location of the stack pointer into ECX, and that's where write's gonna read from. So when the syscall is called again, it's literally just gonna give us the address. The first 4 bytes will be the address of the stack pointer, which then when read is called here, we can put our shellcode where it needs to go relative to this location, and then just jump to it, kind of like a jump ESP when we leak the address. So let's get out of here. Quit, clear, and then let's take a look at our exploit. So I'm going to try and use Pwnable just so I can get better at it. You can see that here. So the first thing we do is establish the connection to the container, port 10,000, host, blah blah blah. This is for if you're doing it locally. You can start a GDB instance with the binary. We're going to read the welcome message. Let's start the CTF. And then we're going to read 20 A's into the buffer. And then we're going to put the address of the move ECX ESP gadget here. So we're going to return to that. We're going to send the payload. And then we're going to read 4 bytes that the server will respond with, which should be the leaked address of the stack pointer. And then what we're going to do is we're going to make our shellcode here. So once again, when read is called, we'll have 20 bytes, and then we'll put the leaked address plus 20 bytes because the stack pointer will be decremented or realigned by 20 bytes because it needs to make room for more local variables. Then we're just going to set up the system call for execve. I'm not really going to go over it. I think with my other assembly videos as well as these tables, you guys can figure out how it works. Basically, we don't need any arguments to pass to bin sh. All we need to do is put bin sh on the stack. Remember, you push everything in reverse order. So you have to push sh first, and then you have to push /bin, and then you null terminate it, reverse it, put it in hex, blah blah blah, and then ESP will be pointing towards the start of the shellcode, so you move that into there, into EBX, which EBX is the pointer to the file name, and then we make our system call, and then we exit. We send the shellcode, and then we use Pwnable's interactive function to hopefully get a shell. So if we run this, I'll just show you what it looks like if you do it with the GDB instance, because it's kind of cool and handy. Comment this. So if you do it with GDB for like local testing, then you can see it pulls up a GDB instance for you, and then you can debug and see what's going on that way. But anyway, this is a handy trick. Comment that. Let's clear this away, and then run it again, and then you can see it works. So it leaks the stack address, which is this, and then it gives us our interactive shell, and you can see we're the start user. And there's the flag right there. So we know we finished the challenge. Yep, it's readable. So that's it for start. That was kind of fun. Like if you don't have enough room in the buffer to store your shellcode there, then you have to leak another address on the stack and jump to that. Like the jump ESP thing, like kind of how we return to that. It's like the BrainPan 1 overflow we did with VulnHub, except with a smaller binary. And hopefully I'll have a video for this one coming sometime soon. Until then, I'll see you guys next time.